Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 33 to 35 of the Algebra 2 Trig New York Regents exam for January 2016. Okay, let's take a look at 33. That says, determine the area to the nearest integer of triangle SRO, shown below. Okay, so before we start determining the area, let's go ahead and write down the formula for finding the area of triangles presented in this format. Now, we have non-right triangles. There are two formulas you can use, okay? The one I'm going to be using is the area formula for SAS situation. So the area formula is 1/2 side times side sine of the angle that's included, okay? So here you can see your SAS. A word of caution that you want to keep in mind when you're using this formula is that the angle must be included. Okay, in other words, the angle must be between the two sides. Must be between the two sides. You can't just pick any angle that you want and use it for this formula. In this SAS area formula, SAS basically means that the angle is between the two sides, okay? So now let's take a look at what we're given here. We have two sides. This is S and S. Now, which angle are we to use to plug into this formula that we have right here? Angle S, R, or O? The included angle or the angle between the two sides is angle R, okay? But angle R is unknown. The nice thing about this problem is that we know angle S and O, so we're going to use the triangle angle sum theorem to determine the measure of angle R first, and then we can now use the SAS formula, okay? So first of all, we're going to find the measure of angle R, okay? By measure of angle R. That's task number 1. Okay, so in order to do that, angle R is basically 180 degrees minus the sum of the other two angles, so 38 plus 17. Okay, and when you plug it into your calculator, you will end up with 125 degrees as your measure for angle R. Okay, now how do we proceed? Now we have our SAS, side angle side. So we can now use the formula, okay? So let me just divvy up my workspace here. The first side is 15, the second side is 31.6, and the included angle is 125. So the area, which is 1/2 S side sine of the included angle, is simply going to be 1/2 times this first side, which is 15, times the second side, which is 31.6, sine of the included angle that we just calculated earlier, which is 125. All right, if you plug that into your calculator, you're going to end up with, let's go ahead and do that. So if we calculate 1/2, 1/2 times 15 times 31.6 sine of 125. Let's make sure our mode is in degree format. Let me switch that real quick. So in degree format here, and enter. And our approximation is 194.134. Okay, so 194 point, I already forgot, 139. But we were asked to round to the nearest integer. Okay, so area is equal to 194 to the nearest integer, because the integer before it is less than 5, okay? To nearest integer. And that is the answer to question number 33. Okay, let's take a look at question 34. It says, prove the equation shown below is an identity for all values for which the functions are defined. So cosecant theta times sine squared theta times cotangent theta is equal to cosine theta. Now, one tip on proving identities is as follows. Whenever you're proving identities, it's always beneficial to express every trig function in terms of the parent trig functions, namely sine and cosine. After after expressing them in that format, then you try to establish equality. Try to simplify and use your properties of equality, and just try to simplify and make the left side equal to the right side. Okay. Now before we get started with this problem, let's do a real quick review of our identities. Just a few identities that we're going to be using for this problem, or some identities that you might see on your upcoming Regents exam. Okay, so the first one are the quotient identities. You have to remember that tan theta is equal to sine over cosine. Its reciprocal trig identity cotangent is the reciprocal of this, cosine over sine. Okay, these two quotient identities enables you to write tan and cotan in terms of sine and cosine. You also have cosecant. This is a reciprocal identity, which is 1 over sine. Be careful, cosecant does not go with cosine, the way it sounds, but cosecant goes with sine. And then secant theta is a reciprocal of cosine. Okay? All right, now let's get back to the problem. We have cosecant theta times sine squared theta, cotangent theta is equal to cosine theta. All right, so goal number one is to express every single identity in terms of sine and cosine if it's not already in that form. Cosecant, we can use our reciprocal identity here to express it as 1 over what? Sine theta. Okay? And then sine squared theta is just sine theta times sine theta. Cotangent, we can use a quotient identity to express that as cosine over sine. Okay? And then on the right side, we have cosine, which is already in the desired format. So we'll leave that alone. All right, so let's focus on the left side, see if we can simplify anything and end up with a conclusive result. So the signs divide out here, that's nice. And then these signs divide out, perfect. We end up with cosine theta equals cosine theta. We have established equality, so we are done. All right, let's take a look at question 35. It says, find the difference when 4 third x to the third minus 5 over 8x squared plus 7 over 9x is subtracted from 2x squared plus 3 over 4x squared minus 2 over 9. Okay, so we're subtracting this polynomial from that polynomial, so we're going to write it in this format, 2x to the third plus 3 over 4x squared minus 2 over 9. That's subtracted from 4 third x to the third minus 5 over 8 x squared plus 7 over 9 x. Okay, so when you're working with the difference of polynomial expressions, there are two things I would like you to keep in mind. Okay, so this is just a brief reminder when subtracting polynomial expressions. Okay, reminder for subtraction: one, always use parentheses. Always use parentheses because of the next point. Always use parentheses. And then step two, reminder two is do not forget to distribute the minus, to distribute the negative. Now that's the beauty of parentheses. That parenthesis tells you that everything in it should be impacted by the sign in front, okay? So the parenthesis is basically setting you up to remember to do the second point, which is to distribute your minus or whatever the coefficient is, okay? So what I'm going to do first is distribute this minus across all three terms in the parentheses, okay? So this now becomes, let's write it over here, 2x to the third plus 3 over 4 x squared. Let me split this apart, minus 2 over 9. No, I don't have to do that yet. Well, I could. And then we have minus 4/3, minus 4/3 x to the third. So minus 4/3 x to the third. Distribute minus to this one, it becomes plus 5/8 x squared. Minus distributed to plus 7 over 9, it becomes minus 7 over 9x. Okay, so all we're doing now is just combining coefficients. The reason why I wrote it like this is I want you to see visually the terms that I'm combining with one another. Okay, since we're just combining coefficients, I can extract the coefficients and work with them one by one, so that I don't make a mess and keep writing the same thing over and over again. All right, so let's go ahead and extract the coefficients of the squares. I'm sorry, the cubes. So for the cubes, we have 2 minus 4 over 3. How do we do this? Put it over 1. Find LCD. LCD of 1 and 3 is 3, so times this by 3 top and bottom. So that yields, what does that yield? 6 over 3 minus 4/3, which is positive 2 over 3. Okay, so when we subtract the cubes there, you end up with 2 over 3 x to the third. Now let's shift our attention to the squares. Okay, now for the squares we have what do we have? 3 over 4 plus 5 over 8. Now we have to find the LCD. The LCD of 4 and 8 is 8, so we'll have to multiply this by 2 top and bottom. So that yields 6 over 8. 6 over 8 plus 5 over 8, which equals 11 over 8. So that is the coefficient of the squares after we add them together. So when we add these squares together, we have plus 11 over 8x squared. 7 over 9, negative 7 over 9x does not have any like term to be combined with, so we'll bring that down. And then the constant doesn't have anything else to be combined with, so we bring that down also. Okay, so this is the result when you subtract this polynomial from that polynomial expression. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions, just include your questions in the comment section below, and we will be glad to provide you with support. More clips coming from math.serve.com. Thanks again for watching and have a wonderful day.